Hello everybody, this is a video about finding the area of composite shapes. I'm Mr. Shirley, fighting the forces of evil through the power of math. Now, I would like you to make a short note for yourself as you watch this video, but it all should be review from last year, so you are welcome to keep your note fairly brief. Okay, please make sure you have a page and date on your note, as well as a title, of course. Makes it look pretty, keeps things organized, makes your parents and Mr. Shirley very happy. So our learning goal is to just explore some methods to find the area and perimeter. Well, we'll just be finding the area of composite shapes. We're leaving perimeter out of this particular video because the area of composite shapes is what we want to focus on because we often need to be able to find that for 3D shapes, to find surface area and volume of 3D shapes. Okay, so that's why we're focusing just on the area. Alrighty, now you should probably jot down some of this, but I'll leave it up to you how much. So a composite figure, in case you don't remember, it's a figure that can be divided into smaller shapes that are the basic plane figures, such as triangles, parallelograms, trapezoids, rectangles, circles, etc. Okay, so a plane figure just means a two-dimensional figure. Okay, so it can be broken down to one of those shapes. All right, and to find the area of a composite figure, you just divide up the regions and find the areas of the smaller shapes, and then just simply add them together. Okay, hopefully this is ringing a bell from last year. So on this particular shape, it's fairly straightforward how you would want to divide this. So in our case, we're dividing it into a square and a triangle. So that's length times width is the area of a rectangle, not a square. Length times width is the area of a rectangle, and then 1/2 base times height is the area of a triangle. With this particular diagram, it's not too tricky to find out which measurement is which, but 14 times 12 for the rectangle, and then 8 and 12 for the triangle, okay? And if you carefully do all that using proper order of operations, which meaning you're doing the multiplying first before the adding, you should end up with 216 centimeters squared. All right, now with this particular example, you could have also treated it like a trapezoid and used the trapezoid formula. Okay, so that would work equally well here. I just like to use it as an example of a composite shape where the smaller shapes are very recognizable. Okay, it works as a good example. But yes, you could treat it as a trapezoid. It absolutely would still work. All right, so to find the area of a shaded region, which sometimes you get questions like this, you've seen them before, you find the area of the whole figure, and then you subtract the area of the non-shaded regions. Okay, usually when you have these sorts of questions, some dimensions are left out, such as the dimensions of that shaded region, so you need to do a little bit of extra work to find it. All right, you'll see that in the example on the next page. Okay, so we're wanting to find the area of the shaded region here. So again, what we're doing, just like you saw on the last slide, you find the area of the whole shape, which is the whole shaded region plus the circle in the middle, minus the area of the non-shaded region, okay, which is just that circle. Okay, remember they sometimes do this with shapes. They have the height outside of the shape itself. So we're certainly not counting this particular white area here. This is not part of the shape. Okay, so the area of the whole shape, hopefully you noticed that this was a parallelogram. Okay, so in order to put this whole thing into a math equation, we have the area of a parallelogram minus the area of the circle. Okay. So that's base times height for a parallelogram minus pi r squared for the circle. All right. Now, one quick thing I just want to note, just a reminder that 4 centimeters here is the diameter. Okay, so that's d equals 4. Yikes. Well, maybe this will bring back some happy memories for you with how bad my writing is on the smartboard using the mouse. Maybe hopefully it's a happy memory. So that means our radius is 2, okay, which is what I'm using down here. Okay, so that's just the radius, not the diameter. Okay, hopefully that made sense. So when we put all those in there, use proper order of operations, and you should end up with 53.4 centimeters squared. Okay. Oh, I had it in a box right here. I outsmarted myself. Way to go, Mr. Shirley. Okay, so ignore my ugly writing. Look at the pretty box. Now, that's our last slide for these. Please make sure to try out the examples I've put into Google Classroom. I've also put the sheet in with the work that some of you will have picked up from the school, so you do have a paper copy of that. If you do have any questions, please feel free to ask me in all the usual ways, and I'm always happy to help. But otherwise, thank you for watching. Have a wonderful day.